So this is a Newton's second law lab, and I have the rubric on the left side, and there's a sample report on the right side. So let's take a look at this report. So title, name, partner name, date, well, those are all there. I removed the student names, so that's good. And then some materials listed, good. Brief procedure and purpose. Purpose to prove that F equals MA is true. That's pretty brief, but that hits the point. So let's move on to procedure. Procedure is not very brief, but let's see if there's anything that looks odd. Turn on the air track, level the air track, air masses, connect string to glider, drift wires. Okay, good. Okay, full gate 1 and 2, 50 centimeters. Press buttons, and read. Okay, that's very detailed. Okay, I don't really have to have all the details. So starting from say step 6 all the way down to maybe step 10, you can say record velocity and get 2 velocities one from each gate. Repeat. That should be brief enough. And okay, right. Okay, procedures are good. And then I want to take a look at the conclusion. See if the conclusion was reflecting the purpose. Okay, objective was proving that. So relative uncertainty of 0.3, relative error of 1. So since that, it was not successful. Correct. But with that, and very close to proving. I like it. It's drawing the right conclusion, although it wasn't really mentioning what was being compared. It mentioned the broader objective is to prove F equals to MA. The exact thing to prove is you'll have an expected mass, the total mass of the glider plus all the clips, and you'll also have a measured mass, which is the slope of your force versus acceleration line. So those two should be comparing against each other. So let's see how much the student had done the calculations to see if I should take a little bit points off. I'm thinking about half a point, not a lot. So let's back up here and look at data. So okay, velocity in meter per second, acceleration. So apparently the student didn't really care about treating zeros. So now it's time to catch up with that. Okay, now showing those. Well, showed some, but not all. All right. So that should tell the student this is important. And okay, the 5 trials for pulling weight, 5 weights, 25 sets of data. I'm not counting, but I think this is the right amount. You can see the acceleration goes from 1 to the 2 to the 4 to the 5 and 6. All right, speeds are accurate to that. Okay, mass, everything is in here. One a couple of values are wrong, I have a point taken off. Okay, so calculation, just results of the acceleration. Okay, that was shown. And also average every 5 trials. So that was here, average. And also the forces were calculated. They look right. Okay, check. Plot force versus acceleration. That was plotted. Applied force, acceleration. Units are correct. And looks like the plot is correct. It's also a nice title. The fit line seems right. So let's skip that. And then average standard deviation of the slope from Linus. Okay, Linus was shown here. Although this wasn't really done, it wasn't really necessary. The intercept wasn't really useful. But since you're showing it, you should make it correct, which means this is supposed to show a 9 here. And that means 3 zeros and 9. 3 zeros, this will show a 7. So you should round that. Let's see how often the student does that. I'll just compound that over here. Intercept and okay. So I'll just compound that over here. calculated relative error 1%. Let's see, 654, and the total mass was what was it? Didn't really give that value. Should be this times 5 plus that. Yeah, close enough. I think it's about 1%. I wish the that total mass was shown. Relative uncertainty is 0.3. Okay, some calculations, errors. What could have caused the result to not prove? So may have not been perfectly level, meaning, oh, well, you said you were going to level it, so this may be less of an issue. Another possibility is the string may not be horizontal. If you checked it, you should say, well, it's probably also not the case. Okay. Yeah, I think overall it's not too bad. I would say 14, 14 and a half, either way. I wish the student had a total mass right here, so that there's expected value, and then there's the experimental value. So that goes back to the conclusion. I was thinking about taking a half point off, and I'm a bit more convinced right now. Not showing expected, or well, let me see. There was something. Well, didn't say that was experimental. So, see, a broad conclusion is good, but you also have to support it with the details. So if you say you got this value plus minus that, which is this relative uncertainty, and you're supposed to be getting, well, the sum, which wasn't shown, then I would be happy to give all the points. But I think 14 out of 15 is a fair grade. This is a pretty decent report. Formatting could be improved, but I'm not picking on formatting. Okay.